In this video, we will try to understand what a nuclear explosion is and what its damage factors are. It doesn't matter whether a nuclear weapon detonates, in the air or on the ground. Immediately after the bulge in its epicenter, a fiery swelling forms and begins to widen. The radius of the bullet will depend on the power of the nuclear munition, on the height at which the bomb exploded, as well as on the features of the terrain. The diameter of the fireball can vary from several hundred meters to several kilometers. Infrared light radiation lasts milliseconds. The fireball, rapidly increasing in size, rises, while the brightness of its glow gradually decreases. A few seconds after spawning, the fireball turns into a swirling cloud. However, in the epicenter of such an explosion, there is almost no chance of survival, because it destroys and burns everything to the ground. In fact, everything evaporates. The diameter of the affected zones can reach more than 10 kilometers, but, again, will depend on the power of the explosion and the method of detonation of the nuclear munition. Therefore, the greatest danger will be thermal radiation. A flash of light and heat will cause fires around and lead to serious burns. A few tens of seconds after the flash, a shock wave will begin to spread from the epicenter of the explosion at the speed of sound, which will simply sweep away everything in its path. It is in second place in terms of destructive influence. Damage will occur both from the wave itself and from the debris of destroyed buildings, lumps of earth and stones. The shock wave will roll further, and the danger will be broken windows and broken glass. Radiation is the third most destructive. Radionuclides, which are formed in the process of radioactive decay, are very dangerous. After the nuclear stockpile burns out, radionuclides rise into the air and after some time begin to settle. The so-called radioactive dust contains isotopes of elements that decay and, accordingly, phone, that is, emit alpha, beta, and gamma radiation. This is ionizing radiation that can accumulate in the body and cause, in particular, radiation burns or acute radiation sickness. A lot of dust rises into the air and causes condensation of water vapor above the ground. This leads to atmospheric pressure drops after the explosion, resulting in radioactive rain. It can also be formed in the event of an underwater explosion. Drops of such rain are extremely radioactive and can cause acute radiation sickness. On average, precipitation falls 10 minutes after light radiation. Another component of a nuclear explosion is a powerful electromagnetic pulse, a kind of super lightning. It kills all electronics within nuclear strike range. It does not pose a threat to human health, but it can be catastrophic for devices from telephones to power plants. After a nuclear explosion, they fail and will not work. At the time of an accident, detonation of ammunition, there is a one-time burst of ionizing radiation that affects living tissues. The penetrating ability of radiation is different. Alpha radiation does not penetrate the surface of the skin deeper than 1 millimeter, so only a burn is possible. Gamma radiation penetrates a person through and can radically damage the structure of DNA. 24 hours after the explosion, the radioactivity decreases almost 1 million times. The products of the nuclear reaction do not live long. They decay quickly. This will be shown by a dosimeter measuring radiation. Atmospheric factors also have an influence. The wind carries radioactive fallout tens and hundreds of kilometers from the affected area, although the main pollution is observed in a 10-kilometer area from the epicenter. A nuclear explosion in a populated place, like other disasters associated with a large number of victims, the destruction of harmful industries and fires, will lead to difficult conditions in the area of its impact, which will be a secondary impact factor.